Hi, in this video I'll talk about numbers and their decimal and binary forms. I wrote a method that converts a decimal form to a binary form and prints a line with its binary and decimal representation next to it. And I prepared a few test cases. So let's run the code and see the result. So as we can see, decimal 0 is represented with 32 zeros. So it's 32 because I use integer, which is a 32-bit signed integer. I'll talk about a signed thing just a bit later. So if you look how 1, 2, and 3 decimal forms are represented with binary forms, it makes total sense. However, if we look so just for fun, I added max value and see how max value is represented in binary form, it may look a bit weird because it's not all ones, it's 1, 0 at the beginning on the left. So that's because the bit on the left represents a sign and 0 means positive. So this number is positive. If it's 1, like in these 3 cases or 4 cases, it is negative number. So the next line is also a bit tricky. It's -1, and it's represented with all ones. So it's not 1, just leading 1 and all zeros, because that's a totally different number like this. It's all ones. So why it's like that? So so how can we get, how many we should add to -1 to get a 0? We should add 1. So if we add 1 to -1, we'll get 0. And if you talk about binary form, let's add 1 to this binary number. And it should be 32 zeros, and there should appear one less bit. So one more bit on the left. So there should be 33 bits. But as our integer can contain only 32 bits, so the bit on the left gets lost. And we get this binary value. So that's maybe a bit weird, but that's how computers work. There is no overflow. And the one more thing we can notice is that if we invert all bits, we'll get absolute number -1. So if we invert all bits for -1, we'll get 0. If we invert all bits for -2, we'll get 1. And if we invert all bits for -3, we'll get 2. And if we invert all the bits for mean value, we'll get max value, which is 1 less than absolute value of mean value. So that's how it works. The one more interesting thing is that if you look at this binary form, what if we add 1 to it? We'll get this. And if you look at decimal forms, that doesn't make sense. However, in C#, if we add 1 to max value, we'll actually get mean value. And by default, there is no exception, which makes total sense from binary representation of numbers. So what doesn't make sense from binary representation is if we add 1 to -1. But this makes total sense. All right, let's just for fun try a few more cases. So we tried signed integers, let's try unsigned integers. Sorry, those 3 cases that don't make sense for unsigned integers. So the results are similar, with the exception the max value is represented with all ones. There is no zero on the left because um, it's not needed. We know that it's unsigned, so it cannot be negative, and we can use extra bit to store extra values. And let's just for fun try long. So long is a 64-bit representation of a number. And if we run the code, we'll see that this binary representation is bigger, it's longer. It's like it contains 64 bits now, but the logic is the same. So the max value contains all ones with the exception of the top of the most left bit. Minus one is all ones, and the minimum value looks like this. Thanks for watching.